get started here, I've talked to some of you. I don't know if you're familiar with AMR technology or not. A lot of times you'll hear our product looped in with something like an AGV. That's a common acronym, something that's been around for a long time. So I'd like to start off just by talking about a little what is an AMR. What is it? How is it different? And how does it work? So we'll do that first. So AMR stands for Autonomous Mobile Robot. So in the past, like I said, you've had guided vehicles that are autonomous, but they're just that, they're guided. So an AMR is an unguided autonomous vehicle. So we do the same things as these AGVs have done in the past, moving product around production areas, facilities, now through moving pallets with distribution, different things like that. You'll see all sorts of different applications. But we use something that's called SLAM technology, and that's how we navigate. So SLAM stands for simultaneous locating and mapping. So as that robot drives around, it's constantly looking at its environment. It's looking for some hard points. And then it sees things like people, forklifts, pallets, the dynamic things that move around in your applications every day, things that stick out from production lines. And it can see those in real time and make real-time decisions where it can either reroute itself or just drive around. If there's room, it'll just drive around the obstacle and go on. It's what we call a global path. So that's what's different. In the past, you look at this right here, if there's cones, the AMR can navigate those cones and keep going even if it's blocked. I'll go forward here, but like an A, go from point A to point B autonomously, but if that is blocked, it can't go anywhere. It's stuck, it's dead in the water. So until somebody moves or until a forklift moves, that thing just sits there. Now we have the ability to fully move around it autonomously. These don't have tracks. They're designed to work around people. They're designed to work around expensive manufacturing equipment, other robots, production lines. These are truly cobots like you would be a little bit more used to a universal robot or something that's made to work around people. These are the same. There's a lot different form factor. So how do they work? We've got a suite of cameras and sensors on the robots, and in addition to some encoders on the drive wheels, which we'll talk about that in a second. But essentially, this is a setup on every MiR robot, from the smallest MiR to the biggest MiR that we offer. Each one of them has on the corner, and if you go in here and look, there are diagonal across from each other, LiDAR, radar, basically. And that gives us a 2D cut of the environment that we're looking at all the way out to about 180 feet, 60 meters roughly is how far that LiDAR can see. So that's an instantaneous live one. That's full 360-degree view around the robot. On the front of the robot, if you look at them, they have two, they're in our case, Intel cameras that are forward-facing, about 6 feet out and 6 feet up, and that gives us immediate 3D data. That's about 170 degrees field of view. So pretty equivalent to what you and I see as we walk, right? So that's the forward-facing. And then there are proximity sensors around the robot itself. There's two on each, out and down about 9 inches, and that's looking for an immediate halo around the robot. So that looks for the stuff that's on the ground, pallets of fork trucks, feet. If you get up close to them, that's usually if you kind of pop out and surprise it, those sensors are what's going to catch it, and it's going to stop so it doesn't run into anything. So there's those three things. They all go together. And then we actually have encoders on the motor, so once we pop that robot down on the map and it travels, it knows I'm right here. Here's what should be here. Camera systems, you see what I'm seeing. So that's how we know in real time how we can make those decisions to travel around stuff. Can we fit, and how we can be fully autonomous. So this is a good example of what each one of those cameras sees. The first one is what we see. We start to the left. We see a chair that sits there. If you go over to the right, that would be the LiDAR. So it's a little bit hard to see here, but basically, like I said, that's a 12 inches off the ground. So it sees the 4 legs of the chair, and it could probably even see a little bit of the seat of the chair, honestly. And then down here, we've got what the 3D cameras see. They actually see the full 3D structure of the chair. And then we put all of those together, and they match them up so it can see that there's a 3D chair there, how high how tall it is, how deep it is, and where it sits. in relation to the robot, and it can just drive around it. So it sees people the same way, it sees pallets that same way. So that's how the robot actually sees what's going on. And this is a good example of a map. Again, it's a little bit hard to see up here, but there are red lines. So this is what we do. This is a robot map. We go in, we map a facility. The map gets stored on the robot itself. So nothing is cloud-based. It all sits on the individual robot itself. So the robot's going to take this map, and we say, hey, we drop it in here, and we match up with the camera. See, this is the first step that we do, so it knows where it matches the data. And then what's missing on here is the 3D point cloud, which would overlay this too. But then the robot travels around there. The encoders say, I'm right here. Roughly, I've traveled this far. This is what I should see. So I equate it to when we drive, when you and I drive, at least I drive this way, I'm looking, especially if it's an area somewhere that I know. I know I need to turn at the blue house. I need to turn at this street, and there's woods right here, or there's a billboard right here. I know I'm getting pretty close to where I need to go. Navigation Works is very similar to that. We look at, basically, we take everything out of here that can be moved. If it's not bolted down, take it out. We leave the hard points, so walls, buildings, building columns, racking, production lines, those things that are there. And we leave that, and the MiR looks for those as it travels around different parts of the facility. So that is how it works. Any quick questions on that? I mean, we see it, we react to it, and we go. Good. So that's great. These are cool. They do a lot of neat stuff if you've seen them. But why? I mean, where's the applications for this, and why are people automating this process? Like, this is a new thing, material handling, a fully automated material handling robot. What's going on? So this is an interesting graph that's from a study. This one was done back in 2019, so it's even, honestly, it's more extreme than this right here because COVID. I mean, automation's been going on for a decade, but I think when 2020 hit, that just took that and accelerated it like crazy. So, but this still holds pretty true right here. So why do people do it? Number one, at the top, the one that sticks out, the orange graph right here, is there's these positions. Like I said, I go all the way up from Texas to Minnesota and everywhere in between, and it's the same story everywhere. You look at a big distribution center, you look at a manufacturing facility, all of them have now hiring signs out front at X amount and instant, and you go to talk to them, and it's the same story. There's nobody there to hire. So how do you optimize the people that you have now? You can do something like this, and you can bring in an automated solution and take those people that are doing that job that's being replaced by the MiR, retrain them, and put them to a value add. We call the tasks that the MiRs do non-value added. So they're critical to the production or manufacturing, but they don't add anything, right? So if there's a human interaction, that person is not adding any sort of value with that touch. So we're shuttling around. Like, think of us like a mobile conveyor. So take that valuable human brain, that expensive human brain, and put it towards something that if they touch that product or interact with it, then they add value to the process. So number one, there's just not a workforce out there. Number two, the cost of that person going up exponentially like crazy. I saw something the other day at a well-known national company that said they were starting people off at $50 an hour full benefits right away, and they still can't hire people. And then, of course, you've got some other factors that aren't on here. We have a need as e-commerce continues to grow and onshoring continues to grow for better process control, better cost control. We have a bigger need for more workers in warehouses and production and manufacturing facilities. And again, that just leads back to the lack of people that are out there to do it. So I don't think that's probably ever going to change. I mean, I think that's something that's here to stay. We can count on it. So, that's why we have a solution like this. And again, what are some of the things that some of the applications that we look at? What are we replacing, so to speak? Obviously, forklifts, running shuttle runs back and forth. You've got conveyors for some reasons, I should say. You need more flexibility in manufacturing these days, and if you can do it on a MiR, and you need to change your process, it's a lot easier to change the logic and the programming on the MiR than it is to unbolt your conveyor system and moving around to change that. Whereas if overnight you really wanted to run a different production or change a couple things, you can do that in a logic, push it to the robots, and the next morning it can be done. And human labor, as we've talked about here, I've talked to several people today that they still have people pushing manual pallet jacks, pushing carts around to deliver back to my earlier points of let's take those people and put them in more valuable positions for them where we can just have a robot doing that non-value added task. That's easy. And again, these things are made to work around people. Obviously, they're cobots. So whereas you might have a forklift that could weigh 5 tons, fully loaded, that can drive 7 or 8 or 9 miles an hour, you replace that with a robot is actually made to not run into stuff, to work around and interact with your production, your conveyors or your robotic palletizing cells. Instead of sending a forklift into that palletizing cell to pick up a pallet, you can now have one of our robots come in and do it nice and gently and just do that all day long, no breaks. So there's a huge, huge safety component to it as well. You wouldn't believe any people I see and talk to that say we had over 300 incidences of forklifts hitting things or injuries. Somebody got their toes run over. I mean, it's like the Wild West out there, some of the things I've seen. So huge, huge, huge safety initiatives and a lot of savings, less accidents, insurance, and so on and so forth. Case in point. So again, this is from 2019, but look at all of the different forklift incidences, which there's roughly, about 900,000 forklifts in the U.S. It's 62,000 non-serious accidents. So think about bumping into somebody, running over somebody's toes, not even including the rack, the bases of rack that get hit, the bollards, the different things that show me a clean forklift, honestly. I mean, I did that for a long time, and they're great. The forklift's not going away, but that's just the nature of the beast, right? They're gonna nick some things occasionally. So this just again leads to, if you can mitigate your risk and mitigate your cost to fix these things, why not take a look at that? So that's why, some of the reasons why people are choosing to do that. I'm going to jump into some of our lifts, some of the applications to give you guys some idea of where these are being deployed. Right now, here's our full product line. We start at the MiR 100, which is about a 220-pound payload capacity, kind of a light-duty robot, all the way up to our new 1350, which gives you 3,000 pounds of capacity. So think about your pallet moving, your double pallets. That's more of the distribution. And in the middle, the MiR 250 is great moving carts with static shelves. People unloading and loading those, dropping off shelves. This thing can even move carts. It has the ability to do that. So a lot of versatility and flexibility in here. And I'll get into some of the top modules that are being developed a little bit. MiR 250, like I was saying, this is our best-selling robot. It's also our smallest one. Its payload's about 560 pounds. So we see these a lot moving carts around, where there's one out here that has a cart that it can come and pick up and engage with and take that cart to somewhere and drop it off, pick up an empty cart. We see this a lot when people are doing supermarket runs where they're replenishing lines. So they come from one area, they get called to pick up a cart, go drop it off, take the empty one right back all day long. Or you'll see these going to the lines and picking up samples off the lines, or picking up carts with samples on them, taking them to quality, running around doing that all day long. So those are good applications here. And then again, the 1350 is our big boy. These are great for moving full pallets around, multiple pallets. Great for once your product gets to the end of the line and it's packaged, what do you do with it? How do you handle it? How many touches can we take away now by using something like this to move it from the end of your line to a stretch wrapper to a staging area in a rack, or for a forklift to pick up on the dock? Here is a short video. This is a workflow video that we have, which is it's a visual of what I was just saying. So what we've got here are the 4 different areas: inbound, outbound, your material storage, and production. So in this case, we've got MiR 500, 1000s, picking up pallets from the warehouse, and they're going to run them to production for replenishment. In the meantime, this is a MiR 250 that's doing one of those supermarket runs. So it's going to pick up a cart. See, it engages the cart, turns around, and it's going to take it to the line where it's needed. Drop that off, pick up the new one, and go back for that one to get refilled. And in the meantime, the full pallets have showed up. We're going to drop them off, and then you've got all your product right there on the line. So think of it this way: the idea is, like I said, forklifts aren't going away, right? But what we want to do, if we could try to keep that forklift in its environment where it is its best, so that's on a dock or that's in the rack, and everywhere in between, we now have a solution that's safe, that's made to work around those expensive lines, other robotics, and people that can do the same job as that forklift normally would be doing, shuttling around. So that being said, here are a couple examples of now what we call top module. So what we would put on top of a robot. In this case, these would be some of the smaller robots. You can get these with big ones. These are a lot of the carts, different carts that we have. So the carts, you can then fasten anything to the top of them if you want. Static shelving. A lot of these are static shelving, as a matter of fact, but like we just saw in that video, put on it. You can also affix static shelving, but also something that's pretty popular is a whole workstation, right? So there's a computer and everything, and that thing can travel station to station. You can do that on the MiR. And all the top modules are powered by the internal power on the MiR. So here's some carts. Here are a couple of the lifts. So we make one lift, two lifts, a shelf lift and a pallet lift. That's all that MiR makes. We have an ecosystem that we call our MiR Go, that we have left the design of the robot very much open to the market, where people can come in and develop their own custom solutions. So if you go onto the website, there is a section there called MiR Go, which details conveyors, lifts, shelves, you name it, even collaborative robots that we put on top. People have already developed their own solutions for it to solve whatever application. But they've come to us and we said, yes, that's good, and it works. And that continues to grow every day. It's a lot like a collaborative robot. What gripper are you going to put on the end of it, right? Or an effector, or whatever you guys in that will call it. But it's the same thing with this, and like I said, that continues to grow and grow and grow. But in this case, here's a shelf lift. This is lifting a cart right here. That's on a little bit smaller one, and what we've got running on here, I think a lot of you have seen, is the pallet lift, where we drive in underneath it. We've got to be able to drive underneath it, pick it up, back out, drop it off, and then shuttle it to wherever we need it to go. Then another real popular one right here, more and more, especially what we call that logistics or distribution, is the roller top conveyor. And these come in all sorts of different shapes and sizes. Big ones, small ones that can manually adjust up and down depending on where your pickup and drop off points are. We now have to do that. Front loading, side loading. And these are great if you fully want to automate that end of the lane, where say you've got a line, as long as you have a power conveyor on the end, we can pull up, dock to it, send an IO, engage that conveyor, turn it on, transfer it over to us, and we drive away, and we're gone. And it could go to a stretch wrapper like that too, where we could pull up, drop it off, go to the other end, pick it up, and then maybe take it to a gravity flow lane for a truck staging area. It just depends on what people's processes are. There's a lot of different. So again, that's all powered off of the MiR itself, and that's probably the most popular thing that we're seeing right now is that power roller conveyor top. It gives you most versatility. And that is about the 10,000 foot overview. So a couple of other things, just to let you know a little bit about MiR ourselves. So we're now approaching, I think somewhere around 3,000 to 3,500 robots worldwide install base. So our first product came out in 2016, and we've at warp speed progressed and added new models on since then. We continue to grow. We have fleets here in the U.S. that are approaching or over 200 robots at a facility. So they pretty much have automated the full facility. So we can go anywhere from one robot up to that total fleet control where we're talking about triple digits. That's simply something that can be done. And we're still, very much focused on R&D and adding new products. You'll continue to see a lot of good releases. I think one of the next big things that we're working on, sorry if I'm letting the cat out of the bag to anybody, but is being able to lift pallets up off the floor and drop them down on the floor. So, we've always got our eyes to the future and our roadmap. We've done a really good job. We have a really great market share here in the U.S. and around 40% now is where we're sitting. And we have a really, really great team of distributor partners throughout the U.S., HTE being a very, very fine one with a lot of capabilities. And we also have a network of certified systems integrators that works with our distribution channel to help with, if it's not just, for instance, a MiR robot or fleet of robots, but we have multiple components, conveyors, software, ERP systems, that type of thing. We've got all of those resources, both internally with MiR that we can help and our network of integrators that we have. So, we're very excited about the future. Thank you, everyone, for taking the time today to spend a little time with me to talk about AMRs and MiR specifically. And, if I haven't had a conversation with you, I look forward to it in the future. So thank you, everybody.